2 plus 2 equals 4. Notice how the spacing changes. Two times 3. We've used a control sequence. Fractions. A third plus a sixth equals a half. We get some funny errors. And now we've run out of space. The very first Pythagorean triple, we used caret for superscripts. The sum of the numbers 1 plus 2 plus 3 plus 4, it's a bit long, it only just fits in, look. The sum of the numbers from 1 to 100, C dots for the gap. Gauss did this as a child, doesn't fit in, what a pity. Neither side fits in. The general form of Pythagoras Theorem, italicized letters for variables. A special case of Fermat's last theorem, this was known to Fermat, a special control sequence. An integral. The work in progress is a bit noisy as it goes on. We introduce a little bit of extra space to make it look nice. Now we've got there, isn't that lovely? To finish, the recursion that gives the Fibonacci numbers, curly braces and underscore. Again, doesn't that look nice? Notice how the N gets tucked up under the F. What we have here is a LaTeX typing tutor that I produced at the beginning of the year. It's rather different than what we saw before, which was intended by Trinket to allow you to edit 5, 10, 20 lines of code. This is designed for problems that have a single line of code as their answer and usually only involve one or perhaps two concepts. The whole widget is structured as follows. At the top is your target, your goal. In the middle is the rendered version of your answer so far. And in the bottom, I'm afraid it's not very clear, there's a data entry box where you type your answer. And your task is to get your answer to meet the goal. So let's see how it works. We all know 2 plus 2 equals 4, but let's just see how it works and pay attention to the user experience. What do you see, what are you aware of when the whole thing happens? Okay, one of the things I noticed is that everything's aligned except the third line. The third line should be aligned in the middle so that there's not a visual dissonance, so that it's all close to C. The next part of the interface is that on the tutor you press the enter key to get a new task. So it's very simple. You type until you get the answer or you give up, and then you type enter. And if you're completely flabbergasted, not shown but further down in the page is the answer to the question. So you can always cheat. You can always go to the end of the page to have a look. So there's an interface here that's designed for a purpose, and it's a specialized purpose, which is single line answers to LaTeX typing problems. As tech experts, we know that to get the multiplication sign, we don't type an X, we type backslash times, a control sequence. Otherwise, it's not much different from 2 plus 2 equals 4. Let's see how it goes. This one, of course, involves fractions, the \frac frac command. And previously we saw with the trinket version that we ran out of room. The input is quite long. We won't run out of room this time, and we'll have a bit more focus, I think, on the intermediate stages, the errors that come up when frac doesn't get its arguments. So that's also part of the interface. It's also part of the feedback that the user is getting as to where his formula is. So let's see it go. One of the things I didn't like about the interface is that the first fraction works successfully, and then the failure of the second fraction, because it's incomplete, causes the first fraction to fail. This is a sort of time machine. It was correct before and then suddenly it becomes wrong. I think this is disconcerting, and if we could fix that, that would be great for the user. So we've learned something from this. Well done. This is a Pythagorean triple. It was used by the Egyptians to construct right angles when they were building pyramids. As tech experts, we know that you need to use the circumflex caret character in order to get the superscripts. In the context of a learner who is at high school, you might want to put some of that information in as part of the exercise so that it fits into the rest of their knowledge. How this thing works, there's no surprises. Again, we saw that the missing exponents caused the previous formulas, which were correct, to be wrong. We ought to fix that, I think, if we can. There's nothing new in this example except perhaps the use of the solidus, the /, in order to get the fraction. Notice that everything will fit in the width of the page because we're vertically aligned rather than having two side-by-side panels. Again, nothing special here. I find it quite satisfying to see the formula pass by in front of me as a sort of marquee. From a tech point of view, there's nothing new here except the C dots for the 3 dots. But perhaps you want to have a few words about what that notation means in mathematics, and also a few words about how this formula might be proved, and the fact that Gauss proved it as a young child when it was given to him as a cursed arithmetic problem to keep the children quiet. Nothing special here. Let's see it go. Here we're introducing a new symbol, the not equals to symbol. Everything else is much as before. When a dictionary defines a word, it gives both the definition and one or more examples of the use of the word. Similarly, some students, some people learning LaTeX, would want to learn along with the symbol, the meaning of the symbol, the LaTeX encoding of the symbol, and some uses of the symbol in context. Here we have a special case of Fermat's last theorem, which was, of course, well, perhaps not of course, known to Fermat himself. Let's see it go. This turns out to be another example where the intermediate forms of the formula are a bit complicated and confusing. If we could stabilize it, that would be nice. Let's see it go. Did you notice that the \int gave a \in the member of set relationship? This formula is a favourite of mine. It's the recursion that gives the Fibonacci numbers. Part of the Fibonacci numbers go 2, 3, 5, 8, which you may recognise as part of my email address. My mathematical work also involves the Fibonacci numbers, so they're a special favourite of mine. Let's see this formula go. Again, we might have some links relating to the Fibonacci numbers and other things as part of this exercise. Some people might like that. Or you might say it's a distraction, it shouldn't be there. That's a matter for whoever's doing the teaching or whoever's setting up the site or whatever. What's right depends on who we're dealing with. There's no one right answer. This last range of examples comes from Learnlatech Org, which was created by the LaTeX 3 project. It's got going about 2-3 months after my project, in other words March, April this year. Joseph Wright will be talking later about this at this conference. I look forward to hearing his talk. I'm going to show how it works for a third plus a sixth equals a half. But before I do that, I want to say that this comparison I'm making is rather unfair, because we have different goals. My goal is a LaTeX typing tutor for math formulas that fit in one line, and I'm able to use MathJax. Their goal is to tutor people, to train people in whole document typesetting, which is a completely higher level of sophistication. To my way of thinking, somebody who's ready to start whole document typesetting with LaTeX is not a beginner. They're an intermediate user already, provided they have mastered the mathematical formula part of LaTeX. So the comparison we're about to see, as I said, is a little unfair because it's comparing apples and oranges. They're both good, they're both similar to each other, but they're good in different ways. They have different purposes and they fit into the world in different ways. So I don't see them as competitors. I see them as doing different things. That said, let's see the example. And at this point, it's quite interesting. Nothing happens. There's no automatic online preview. Nothing happens. You have to move your mouse and click on one of these two buttons, Open in Overleaf or LaTeX Online. This is because the rendering process is so expensive that it can only be summoned manually. It will just be chaos if we try to render the formula keystroke by keystroke as we saw in the earlier examples. This doesn't make it better or worse, it makes it different. And because they're doing whole document typesetting, they have to take some sort of approach like this. Although Jim Carlson's talk on mini LaTeX takes a different approach, which is intermediate between the full LaTeX approach and my single formula approach. So there's the single formula approach, the mini LaTeX approach of Jim Carlson, and the full LaTeX approach of the LaTeX 3 team. So I'm going to move on to how we solve this problem. So to remind you, this is where we got to. We've entered the formula and we have to do something for the compilation to take place. We have to move our mouse or cursor and click on the LaTeX Online button or the overleaf button. But before we do that, perhaps a few words about thank yous. So the LaTeX Online button was provided by Tornad. Well, not the button, but the service behind the button was provided by Tornad. And the overleaf button was provided by, well, Overleaf, of course. And we have two talks from Overleaf and a talk from Yuan later in this conference. I'm looking to them, all of them. So let's now see what happens if we click the LaTeX Online button, which will send our little document across the internet. A service will compile it for us and return it to us, and our browser will display the resulting PDF. It will be a PDF we get. So let's see what happens. Well, it's come back quite quickly, not instantaneously, a second or two. A lot will depend upon, well, the internet really. But where's the formula? Well, this is interesting because the formula is actually off screen. It's further down. Because this project is aimed at whole page, whole document typesetting, it wants to display a whole page of typeset material, whereas all we're providing is one formula. So, as I said, this is an unfair comparison. The LaTeX typing tutor is aiming to do one thing. The Trinket.io tool is aiming to do something quite similar, and Jim Carlson's mini LaTeX is somewhere between the one end and the other. This is a very important page. It was created by users of Math Stack Exchange to record and share their use of LaTeX. By the way, MathJax is a LaTeX interpreter for web pages. This page is full of extremely valuable resources. It could be the basis for a widely used and useful help system for LaTeX. And if it was added to interactive examples, so you could take the examples and modify them to give you what you want, that would be really very helpful indeed, and would make LaTeX very much more helpful and attractive, I think, to new users. Let me go through this page fairly quickly so we can see what there is here. Well, the first thing is it has been viewed 1.1 million times. It's a very important page. It has an enormous number of credits and it's an active page. This is one of the most important pages on mathematics.stackexchange. Here we've got Greek letters, superscripts, subscripts, grouping, which we've seen before. And do you see this sort of stuff? It would be nice to have it interactive, the way in which braces interact with superscripts. We've got parentheses of various sizes, sums and integrals, fonts, fractions, we did fractions, radicals, lots of fonts, special functions, special symbols, currently supported LaTeX commands, accents and diacriticals. And then here we've got a list, an alphabetical list of contents of MathJack titles by MathJack topics by title. So look at this. Isn't this something?